First of all, that looked awesome. I really enjoyed seeing the end of your fitness, and I saw Jasleen had her yoga mat out, and I saw Jadiel's dance moves, and Ethan T, your puppet, which is really cool, but you need to make sure that goes put away now, okay? So let's take another 30 seconds to make sure we have our science in front of us. That's in the Wednesday daily packet. They were spending one more day on heat energy, so it says thermal energy, flow of heat. I'm going to share my screen to show you the connections, and we're going to spend 2 minutes on them. Okay. Oops. So here are the connections questions. You can look through your packets to find the correct questions. It should say thermal energy at the top in the Wednesday packet. Our 2 minutes for connections is going to start now. Pencils up. Eyes on your paper. When you're finished with all 4, you can give a thumbs up. Shes, since you can see the questions on the screen, there's no reason you shouldn't be answering the questions. You can write down your answers on a separate piece of paper. Jameer, are you completely done with your connections? Okay, so set that aside. We've got 40 more seconds. Rodrigo's done with all 4. Thank you for the thumbs up. Makan's all set. Liam, I'm assuming you're all done. Okay, see your thumb, yeah. Johandi. Yandel, can you move your background back to regular, please? All right, that's time. Hands up and on the screen. Number 1. Oh, I'm scanning through everyone's windows and I don't see all hands up. Number 1, clap for A, B, C, D. Correct answer, C. Give yourself a check or X. Number 2, hands back up. Clap for A, B, C, D. Correct answer is B. Number 3, clap for A, B, C, D. D. And number 4. Let me get a show of hands who's at 100% so far. Okay, a lot of us. Great. So this will be our last one. And wait and see if you get 100. Hands up for number 4. Clap for A, B, C, D. It is C. I see some 100%. If you got 100, you can show on your face or on your hands. Okay, and we're going to flip our page. And we're on the next page in 5, 4, 3, 2, 1, and 0. All right, so let's sit up nice and tall. Our face is on the screen. Teachers, quick check-in.
Yep.
Are you seeing me speak or are you seeing the PowerPoint?
PowerPoint.
Got it, thank you. All right, so coming back onto the PowerPoint. Here's our science fact of the day. The first person to light a house using electric light was an American named Moses Farmer. In 1859, he used electric lamps that contained a glowing platinum wire. The energy was supplied by batteries. Huh. All right, so agree if you've ever seen an old-fashioned lamp like that. Maybe in a book or even a movie. Interesting. All right, so curious, what does this have to do with energy, since that's what we're learning about? Let's call in a random person, Mr. Vasquez.
Danielle.
It connects to energy because you could use energy to turn things on. So when you have batteries, those batteries make light energy.
Ooh.
So light.
Nice job naming the type of energy. Great job. All right, so moving on to our next slide. And looking at your page, we're going to fill in the blanks. Heat moves through 3 ways: conduction, convection, radiation. Take about 45 seconds to write these words onto your paper now. Pencils up. Nice job, Sheh. Nice job, Yandel. Nice job, Jason. Okay, we're wrapping up in 10, 8, 7, 6, 5, 4, 3, 2, 1, and 0. Okay, pencils back down. Show on your fingers, fist up, and on the screen. How many ways does heat move? We just wrote it down. How many ways does heat move? 3, 2, 1, show. Okay, I'm seeing a bunch of 3s. Say them with me at the same time. I want to see your lips moving. They are conduction, convection, radiation. You know what? Just while we do this, I'm actually going to stop sharing my screen, if I can figure that out. Okay, so then we can practice saying it without just looking at it. So fist up on the screen. We're going to count it across on our fingers 3 ways. Fist up. Conduction, convection, radiation. Start over. Conduction, convection, radiation. One more time. Conduction, convection, radiation. So these are 3 ways that heat can travel. We're going to do a little reading to see what these words really mean. Okay, before we read, when I say heat travels, can you think of any examples where heat passes from something to another thing? Let me hear from one person who has an idea.
The mirror.
Like, let's say you're cooking maybe like soup, and then there's like a lot of smoke, but then you pour some soup into the bowl. The heat goes into the bowl.
Agrees, disagrees, if you've ever experienced that. Put something hot in the bowl and then the bowl is hot. Yeah, I should see way more hands, you guys. Thank you for that example, Samir. So you can use that in your mind if you want. Think about the example with the hot liquid in the hot bowl. When we do our reading, you could be asking yourself, is that called conduction? Is that example called convection? Or is that example called radiation? Because there's actually 3 different ways we're going to learn about. All right, so coming back to the PowerPoint, we're going to be reading. We can take volunteer readers for people who had shown nice level of participation so far, Mr. Vasquez.
Yep. We'll take Jadiel.
Okay, so thermal energy flows between materials that have different temperatures. Thermal energy naturally flows from warmer substances to cooler ones. When people talk about the flow of thermal energy, they often use the word heat. conduction, convection, and radiation are three ways that heat moves.
Excellent. Let's continue on to read more about each of those ways. New reader.
New reader is going to be Jaden.
Okay, so pause, Jaden. Can everyone show me your pencil in your hand, please? I want to see it on the screen. Show up your pencil. Okay, as we read through this next paragraph, I want you to underline a detail that tells you what conduction is. All right, Jaden, go ahead.
Conduction is the flow of heat between objects that are touching. The stove heats the pan above it by the conduction. Conduction can also happen between different parts of the same object. For example, the part of the handle closest to the stove will also heat up as part of the handle gets warmer. Its
Molecules.
molecules conduct heat to neighboring molecules. The entire handle can become too hot to touch.
Excellent. I'm going to pause sharing for a second so we can discuss this. What did you underline for what conduction is?
See, Kylie.
I underline conduction. Conduction is the flow of heat between objects that are touching.
Agrees, disagrees if you underline the same thing? I'm scanning, I'm not seeing. I should see it. Agree, disagree. Wow, okay, a lot of people underline that same one. Okay, so things that are touching, for example, it said the hot water in the pot or the handle of the pot can get hot. So thinking about Zamira's example with the soup coming into a bowl and the bowl getting hot, does that sound like conduction? Agree or disagree? 3, 2, 1, show. And now if you're not sure, and I haven't told the answer yet, is the hot liquid touching the bowl? And is the bowl getting warm because it's being touched by something? Agree, disagree? 3, 2, 1, show. Okay, so that is conduction. Let me see those pencils again. Okay, so into our chart, we're gonna make a note for conduction that says conduction is between objects that are touching. Example, touching a hot handle. Let's take like 20 more seconds. Nice job. Thank you to the host. Trying to make it a little more clear. Okay, so we're going to move on to the next paragraph. We're going to be filling in this chart together. We'll have a chance in breakout groups to discuss other examples of these things. So as we go, you can be thinking of those examples in your head. In fact, if you come up with one, you can even like tap your head to kind of show like, I have one ready. All right, I'm going to come back to sharing the PowerPoint so we can continue reading. Mr. Vasquez, who's our next reader?
Our next reader will be and Melanie.
And you know what? You, Melanie, pause. Let's have our underlines ready as well. So pencils up. Okay, when you hear convection, underline a detail. Melanie, go ahead.
Convection is the movement of warm liquid or gases to cooler areas. Have you ever felt how warm a kitchen gets when the oven is on? You feel the heat indirectly as the heat moves through the room from convection. The oven heats air inside it. Particles in the air move faster and travel up into the rest of the kitchen.
Okay. What did you underline? I'm going to stop sharing now. What did you underline?
Let's go with Madison.
What did I underline? I underlined that I underlined it.
You need to have it ready, Madison, and follow along while we're reading.
Okay.
Read us the topic sentence of paragraph 2. Okay, so it seems like maybe you don't even have your materials in front of you. Let's go to someone else.
Right. Next person will be Rachel.
I underline convection is the movement of warm liquids or gases to cooler areas.
Agrees, disagrees? Okay, did we all pretty much write down that first sentence? Yeah, that kind of seems like the definition of it. Okay, so now into our box. I don't want to write that because that's a really confusing way to write it. There were a couple words that the text kept saying. Air, air. Is air a gas? Agree, disagree? 3, 2, 1, show. Yes. So when it says it's like through a gas, it's really saying through air. So in my box, I just wrote moves upward through air. Jot this into your box. Now you notice I did not fill in the example. So when you're done writing this down, what is the example that the text told us? You see Nana's got it ready, Kylie's got it ready.
You want to pick out somebody? Okay.
Oh yeah, sure. Okay, Kylie, what's the example from the text?
The example from the text was when it said the oven heats air, particles in the warm air move faster and travel upward into the rest of the kitchen.
I'm jotting this as you were speaking, okay? So, because that's a great example, is that when the oven is on, it makes the whole kitchen hot. Have you guys ever experienced that, like in your own house? You're like, it's hot in here. And your family's probably like, oh yeah, the oven's on, I'm cooking something. Okay, let's take like 10 more seconds. 6, 5, 4, 3, 2, 1, 0. Okay. So let's quickly check in because we've read 2 things so far. Anselmo, eyes. Conduction is touching. Conduction is touching. Show with your hands. Conduction is touching. Convection moves up through the air. Let's read about how radiation is different now. Coming back to the text, Mr. Vasquez can choose our last reader.
Let's go with Emery.
Okay, before she reads, have your pencils ready. You're going to underline your detail. Go ahead, Emery.
Radiation is the movement of energy by electromagnetic waves. All objects radiate heat, and hot objects radiate more than cool ones. When the sun warms your skin or you sit near a fire, you feel radiation. When radiant energy hits you, the particles in your skin move more quickly. Radiation is converted. converted to thermal energy, and you feel warm.
Great. Thank you, Emery. What did we underline for that one?
Emmanuel?
So I underline that radiation is a movement of energy by electromagnetic waves.
Agrees, disagrees. 3, 2, 1, show. Lewis V. Eyes. Thank you. Great job on this first page. All right, so we're going to jot into our box then what we read in the text. Rephrasing it, I said moves outwards from objects through electromagnetic waves. Okay, I included the example. I can sit next to a fire and still feel the heat because the heat's moving outwards from the fire. Ten more seconds. All right, pencils down, sit up, hands on the screen. Watch how I'm gonna do it and then we're gonna do it together. We've got conduction, convection, and then it goes like this, radiation, because the waves are moving outwards. Okay, so it's conduction, convection, radiation. Let's try it all together. Everyone's hands are up. Conduction, convection, radiation. Conduction, convection, radiation. Pause. So these hand motions are for a purpose because conduction is what? Touching. Conduction is touching. How does this hand signal show us convection?
I drove.
This shows up convention because convection is moving up towards the air and our fingers are like basically like moving up.
Agrees, disagrees? Okay, and how is this showing radiation?
Naya.
That shows
Radiation.
radiation because it's like showing all the waves from the electric. It's showing all the electric waves coming moving outward.
Great. Okay, so one quick point to notice, the radiation can usually be in different directions too, because the sun gives the electromagnetic waves downwards, a fire gives it outwards. So sometimes you'll just need to think if the heat is radiating and somehow outward from an object. Okay, in our breakout groups, teachers, let's just focus on the picture and we'll discuss with the groups, how do we see the 3 types of heat transfer in this picture? If scholars came up with different examples, they can share those too during that time.
Okay, how long do you want to go?
4 minutes.
4 minutes? Okay. All right, going out to breakout rooms.
Hello.
Manuel, keep yourself muted. Okay, so who can share how we see one type of heat transfer in the picture? I see Nana's hand up. Go ahead, Nana.
We see in this picture.
Yeah.
We see heat transferring in the picture because you can, and at first when it says convention, it says it shows arrows that that are going up to the hands will show that the hands are hot. And in conduction, is you see like I think it's a stick. When it's on the fire, then it gets hotter. And radiation is when as you can see that the hands, the radiation is going towards the hands.
Thank you, Nana. Can you mute yourself? I lost the button. Who wants to explain it in a different way? Maybe let's look at convection specifically. Go ahead, Miriam.
Wait, I think like I would explain convention differently. Is how it's like since I see like the hand, it's like how the convention like the heat is like going up to the hands, and then since yeah.
Okay, pause. We're not using the chat feature, or you're going to have to watch the lesson video after class. So who can explain the difference between convection and conduction? Miriam, can you mute yourself since you just shared?
Yeah.
The difference between convection and conduction. Go ahead, Liam.
The difference between convection and conduction is that conduction is heat moving between two touching objects, and convection is heat that's moving upwards.
Thank you, Liam, and thank you, Marian, for evaluating. You're right. So with conduction, it has to be touching, right? So who can give us some new examples of one of these three different ways of heat transfer? Who haven't I heard from yet? Jariel, I should see you on your camera. Madison, I should be able to see your face. Go ahead, Jade.
Some way that you can see convection is like if you just got something that came out of the microwave, or it was on in the oven or something. Sometimes there's smoke fumes like coming out of it, and like when you look at it or you like feel it, you can like feel the heat coming on your hands.
Thank you, Jade. Excellent. So raise your hand if you've ever baked a cake through a box. Have you ever used a box cake? So when you read the instructions for baking a box cake, you'll see convection oven. That'll be in the directions if you're using a convection oven. So now we understand what that means. It means that the air inside the oven is making the cake hot. So who can give me an example of radiation? I've heard from Liam. Madison, can you give me an example of radiation?
An example of radiation is when you sit in the sun or you sit by a fire.
Great, perfect. So the heat is radiating from either the sun or the fire in those examples. So go ahead and press the button for return to main session.
Marshmallow over the fire.
Mm-hmm. Ms. Lorton's group is back.
Thank you, Ms. Lorton.
It's like
all right.
Yes.
Thank you, Shet. I'm going to put you back on mute since everyone's coming back now. All right. To the teachers who are back.
Sorry.
To the teachers who are back, now you're seeing faces, right? Not any shared screen. Okay, thank you, Ms. Diaz, for nodding. All right, so Mr. Vasquez, I'm going to ask you to locate two people in the participants list.
Yes.
We're going to hear from my group. Well, to everyone, welcome back to the whole group. We're going to spend this just a couple minutes to share out your own examples that you might have, and you have to tell. Actually, no, don't tell. See if the rest of the group can see, is it conduction, convection, or radiation? Okay, so starting in my group, I'm going to hear from Augustine. Augustine, you're going to give the example you gave with your dad, And then we're going to hear from Joe Hondi giving the example with the microwave. Okay, so if you could unmute both of those people, then they can start out.
You said Joandi and
Augustine.
Augustine. Okay.
Okay, so Augustine, let's start with you. And then you guys, when you hear Augustine's example, show with your gestures which one you think it is. Augustine, go.
There you go. Found them. All right, Augustine.
Because one time my dad was making popcorn, and then
On the stove.
on the stove, and then he brought it back to the table, and then I was reaching out to get a popcorn, but then I accidentally touched the pot and it burned me.
Okay, showing with your gestures. Conduction, convection, or radiation. 3, 2, 1, show. It's conduction because he's touching. Tracking Joe Hondi now.
Joe Hondi, you're on.
If you open a popcorn bag and it was in a microwave and you open from the top, and you put it too close to your face, your face is probably gonna burn because all the heat.
Don't tell us why. Thank you, John. So if you guys think about microwave popcorn opening that bag, your face could get hot. So showing with your gestures. Conduction, convection, or radiation. 3, 2, 1, show. David, Ryan, Zamir, let me see it. Ethan, let me see it. Okay, why is this one convection? Andrew, I got it, Mr. Vasquez. This is convection because?
This is convection because when you open the popcorn bag, like all the heat is gonna come to your face if you do it closely.
And I know that convection is moving.
It's moving upwards.
Through the
air.
Say it if you know it. Through the
Air.
air. All right. We can take one last example. Raise your hand if you have any kind of example at all for to share with the group.
All right, we have. Let's go with Jason.
What were you mostly thinking? Wait, what was the question again?
Oh man.
We'll call on someone else.
Anyone else? Let's see. Yandel. You won't let me. There you go.
When I wash my hands, I rinse my hands with, I don't know, the blow dryer.
Oh, like in a bathroom, like when you turn on the air dryer. Ooh, that's a cool one. So what do you guys think with your gestures? Conduction, convection, or radiation? 3, 2, 1, and show. I'm not going to say it just yet. I'm going to call on Jasleen and then Jason. I got it, Mr. Vasquez. Jasleen, why are what are you saying and why?
I'd say it is radiation because when Yandel uses his dryer, the energy comes through it comes outward from objects.
Gotcha. Agrees, disagrees with Jasleen. And let me hear from Jason now.
I think it's convection because it's like the dryer is like hot when you put your hand under it, and like it warms up your hand and then you start feeling hot. So like it's like a type of air coming out the dryer.
Agrees,
There's
disagrees with.
There's a type of air coming out the dryer. So it's like, so there's air, like I think it's convection.
Okay, thank you, Jason. So you guys, you got to make a vote, right? Jasleen's saying it might be radiation because it's coming out, but Jason's saying, yeah, it's coming out through air. So is it radiation or is it convection? Show your final answer with your gestures. 3, 2, 1, show. I'm so glad, Yandel, you brought this up because this is actually convection because it's moving through hot air. And I want you to think of radiation as just if something was hot and was just standing there, would you feel its heat? Okay, like a heater, like a hot radiator pole. It's not blowing air out. It's just sort of coming off of it. If it's air being blown, then it's convection. Okay, we're going to move into IP because we are short on time. We should have enough time to get through. Here's what I want. Number 1 and number 3. Okay, pencils up. We're going to do number 1 and number 3. We have 1 minute. Okay, 1 minute. Go. I don't have the IP ready to pull up for those of you without materials. You'll just need to wait. Okay, eyes on me. So for this one, you're going to shout using sign language. This is A, like agree. B, let's just do it kind of like our disagree. That can look like a B too, right? So A, B, or C. All right, so number 1 for the first one, show out. 3, 2, 1, show. The first one is C because it's got that word touching. The second part of number 1, okay, now you're going to show your letter on your hands. 3, 2, 1, show. Okay, so this is coming from our definitions in our reading. It's A. If you ever see electromagnetic waves, you have to automatically know it's radiation. So that means our last one is B. Let's move on to number 3 and clap it out. Hands up. Okay, clap for A, B, C. The correct answer is A. Thumbs up if you got it correct on number 3. And how did we know, Edgar, that it was conduction?
It was conduction because since you're using the heating blanket to get warm, it's like you're still touching the blanket, and I think people got confused with radiation because since it's a heating blanket, like the heat of it, I think they got confused.
Got it. Okay, right. So since it's touching you, that's why. All right, thank you. You did a great job today. We're continuing on talking about this. Where's Edgar? We got him.
Got it.
And so now we are ready to move on to read aloud.